Welcome back. This is episode 23. Parameters should not be in contexts. I'm Reed Evans, and I'm on Twitter at ReedandEvans. And this episode was assisted by a coworker of mine, Tyler Jennings, who's on Twitter at JenningsTCJ. We were working through a little bit of a refactoring, and we came across this thing that ends up happening a lot when people are getting into functional programming. I know it happened to me a ton. It still happens to me because it's a process. This is not exactly a hard and fast rule, but a lot of times it can help to simplify things. So what do I mean by parameters should not be in contexts? Well, let's take this function here, double array. So what we see is that this double array takes an array of numbers and returns an array of numbers. So what it does is it takes some x's, and the first thing that it does is then it maps over it and then passes our lambda here to actually double. So if we actually call this, you get what you would expect. You get 2 and 4. Right? So this makes sense. No worries there. And in this case, where we're just talking about numbers, that's not that big of a deal. But what I want to show you is that if we were to actually write this function a little differently, it would be trivial what we're actually doing. So let's start off by looking at what we could also write. Instead, we could just write double here as a function, right? Takes an x, multiplies it by 2. And then, in our calling code or whatever, we could call map, and we could pass that double, and we could pass 1 and a 2. What we could also do is just call double with a 4, right? Or any other number, because double is just a simple function, right? It's a trivial function. What we can also do, because in this case we just have a function from a number to a number, because we have map, we can use that exact same function if we're dealing with maybes, because maybes are functors, and map is a way to get into the value, to be able to run a function on the values contained within this maybe. So we can do all of these things, and it's very simple. One of the other benefits that you're going to get here is this type signature is way more telling than this type signature. And why is that? Because double here is telling us that we're going to take a number and give you a number. Double array says, give me an array of numbers, I'll give you an array of numbers. What this does not tell you is whether or not this array's size is the same as this array's size. And that's a big thing. If you had something like dependent types, you could actually, kind of quantify that within your type system. But we can't do that here because we can't say that an array of size n goes to an array of size n. One way we can do that is to say that given one number, I'll give you another number. That's a very, very different implementation that we would have, and versus, if we said that given a number, I'll give you an array of numbers. It'd be a much, much different function. So by doing it this way, we're very, very explicit about what this function needs to take, and we can use it all through here. Now the astute watcher will also see that we could have done a lot of that up here with this map. So I'll take a quick diversion at the very end here because I've got about another minute and show you some other cool, fun things that we can do with this. So in this case, we're calling map that's on the prototype of whatever this object is because we're in JavaScript. If we were to switch it around and call the map function from Lambda, we would get double array 2, just to give it a distinct name here, right? But this does the exact same thing that this does. It's just that rather than calling map here, we call map and pass the predicate and then pass the data. What's interesting is that since map, in this case, is a curried function, and because x's are our parameter here, and they're the last argument that we have to the only function that we call in here, we could actually then go ahead and make that points free. And what we end up with is that double array 2, and double array 3 are all the exact same thing. And so you see how trivial this function actually was, is basically we're just calling map with x times 2 And that's not really providing any additional value that x times 2 wasn't providing for us already. So hopefully you see a few different things here. The takeaways I would say are, sometimes you may want to pass a value in a context, but you're already starting out with some complexity when you do that. There are times for it, but especially when you're starting out, I would say try to keep from doing that. In this case, we're just dealing with numbers, but if you had a complex object that has properties that had arrays and such, you're going to have multiple maps or chains or whatever all within here. There's no reason really to start with a map. Let the calling function map into a function that doesn't know about the array context or whatever. And the other thing I would say is that in addition to the added simplicity of that, this is a much more explicit type signature for what the implementation for this function is than what this might be. So there you have it. Parameters should not be in context. Once again, thanks to Tyler, a coworker of mine here at ResultStack, for helping me out with that a little bit, and giving me some nice fodder for some episodes through some refactorings. Thanks again. Episode 23. I've been Reed Evans. Thank you.